Good morning, everybody. Oh, that wasn't too good. I know it's Friday. I know it's kind of early in the morning after a party at Universal. But let's try that again. Good morning, everybody.
Good morning.
A little bit better. Not as good as the crowd yesterday. Speaking of crowd yesterday, how many people were in that crowd yesterday? So you know the jokes are all going to be the same. I don't know if you want to stick around for that. Welcome to the Case of the Unexplained. My name is Mark Russinovich. Before I get started, I'll just give you a little bit of background about where I came from, who I am, what I'm doing now, for those of you that might not have been following things closely. A couple years ago, I joined Microsoft. I'm a technical fellow in the Core OS division in Windows, and that's the highest technical title at Microsoft. There's about 20 technical fellows, including Dave Cutler, the original architect of Windows NT. So I'm in some awesome company as a technical fellow there. I work kind of day-to-day on tactical things over Windows 7 development, architectural issues, design issues, working with teams about potential features. But most of my time is spent looking further out at architectural directions for Windows that you would first see the impact of in Windows 8 and beyond. Before I came to Microsoft, I co-founded a software company called Sysinternals Software back in 1996, and I also founded a freeware website called Sysinternals at the same time with Bryce Cogswell. Both Bryce and I joined Microsoft, and I get asked a lot, have I moved to Redmond? Yes, I've moved to Redmond. I also get asked, what do you think of Redmond? What do you think of Seattle? And to be honest, the weather completely is horrible. And so that's a big downside. The deal was definitely made it worth it, though, so I can't complain too much. You might know me also from the Windows Internals books. I co-authored the last two editions, and you can see there the cover of the next edition, the 5th edition, which I'm currently working on. I'm behind on my chapters, of course. But we've got a third co-author, Alex Ionescu. Some of you that follow operating systems work might know him from the React OS project, which is a free open source clone of Windows. And we thought he did some great work there, so now he works for us, and not on that. And, of course, I speak at conferences like this. Microsoft lets me out of my cage every now and then to come and speak like this, which I really enjoy doing. So, and I wanted to mention one more thing. Speaking of Sysinternals, I also get asked a lot, or people are under the impression that there's some massive team now of Sysinternals people now that it's part of Microsoft. What's really cool is that Sysinternals today is exactly like Sysinternals was before the acquisition. It's me and Bryce Cogswell writing the tools in our spare time. We've got one program manager who runs the site and interacts with the forum moderators and manages the forum, and that's it. So it's a lot of fun. It's kind of a hobby still for us, and it's awesome that Microsoft kind of preserved that whole operating mode for Sysinternals. Also, I want to mention one more thing about Sysinternals before I get into the content here, and that's Sysinternals Live. How many people have heard of Sysinternals Live? Raise your hands. So not all of you, but Sysinternals Live is a web service that we published a couple of weeks ago now, which makes the tools available directly from the web. So if you go to live.sysinternals.com, you will see a directory listing of all the tools. Simply clicking on one of them or entering the URL to the tool will launch it, or you can access it as a share, whack, live.sysinternals, / live.sysinternals.com tools with the tool name following it, and then you can run the tools directly from there. So it's kind of the philosophy of software as a service. Ironically, it's not built on some big back-end data center or new web technology. It's actually built on Windows 2000 WebDAV technology. So it's simply a WebDAV share being served off of IIS to provide those tools. So let's talk about the case of. And what is the case of? Well, it's troubleshooting. And I've divided the troubleshooting here into an introduction where I'm going to talk about what exactly I'm going to talk about with respect to troubleshooting. And then I've divided a number of cases into different categories of symptoms, including sluggish performance, error messages, application crashes, and blue screens and system hangs. And troubleshooting here, it refers to the fact that lots of applications don't really do a good job of reporting errors, and oftentimes will exhibit sluggish behavior kind of mysteriously, either temporarily or endemically. One of the reasons that you kind of run into this on a fairly regular basis is that applications developers don't test for the unexpected code paths. And those are the error paths. Those are the ones that result when conditions aren't the way they were when the developer tested the software in their own environment or the testers tested the software. So if out in the field this software runs into a corrupt registry value, runs into a missing file, it takes the code down a path that the developer didn't intend, didn't verify, and that causes a lot of strange symptoms like a bizarre error message with hex code, which are my favorite type of error messages. It will result in an error code that's misleading. So it will point you at another root cause and not the real one that led to that dialog showing up. Or it will result in the application crashing or behaving in other mysterious ways, even slowing down. How many people, by the way, have experienced sluggish system behavior or application behavior? And just running Vista by itself doesn't count. So raise a hand. How many people have encountered a blue screen in the last week on Windows? How about the last month? So that's actually pretty good. The last time I asked that, about 6 months ago in audience, almost everybody raised their hand. So it looks like we're making some good progress. Although I think it's a little depressing that only half of you raised your hands. I'm excited by that. How many people have experienced a hard hang in the last week? Wow, that's more than I expected. How about the last month? A hard system hang, lock up, can't move the mouse. So quite a few of you. So I'm going to talk about how you troubleshoot those kinds of problems as well. And the purpose of this talk overall is not to just give you a recipe book for, hey, I've got this problem and I follow this checklist and boom, out pops the answer. What I'm going to do is give you the tools and techniques that you can use yourself on problems as they arise. And applying your brain, applying the things that you learn here and applying the things that you learn after this session as you use the tools, figure out the best way to go attacking a problem, figure out the way to find clues. I'm going to show you along the way how to interpret process and thread activity, how to interpret registry activity. Call stacks are critical. Understanding the way to interpret call stacks are a critical piece of troubleshooting. And I'm going to also show you just how easy it is to perform basic crash dump analysis, whether it's application crash or a system crash blue screen type. Everything I'm going to show you here is a real problem. It's a real case study of a problem that I've experienced, Dave Solomon experienced, my co-author in the Windows Internals book, or has been sent to us, or sent to me by people out like you that have used the tools to solve the problems. I've been asking people to send me case studies so that I could share them with audiences like you. And at the end, I'm going to also ask you guys to share any of the solutions that you come up with using the tools with me so I can share them the next time. Consider this part 2 of the Case of the Unexplained webcast, which is a recording of this session from Tech Ed IT Forum in November. How many people have seen that webcast? 3. Okay. Well, that's really kind of depressing to me because I went to all this work to put in new case studies, figuring that everybody had seen that and would be all annoyed and give me low marks for, hey, this is the same stuff I saw on the web. So it looks like I did all that work for nothing. No, actually, it's good stuff. Consider this part 2. Go definitely, if you like this content, go watch the webcast because it's completely different case studies. And there's some techniques that I show in that I'm not showing here. So they're really best viewed together. Some of the tools that we're going to use include the Sysinternals tools. And if I say so myself, they're pretty good. You can get them from Microsoft.com, TechNet Sysinternals. The tools that I'm going to show, there's about 80 tools on the site. I'm just going to be highlighting a few of them in this troubleshooting sessions. Process Explorer, Process Monitor, Autoruns, Strings, and Zoomit. So I'm going to be showing Zoomit, a tool. How many people have seen Zoomit in action? Almost everybody, so you already know about Zoomit. And Spy++ is a tool from the Visual Studio tools that comes with Visual Studio. You can get that, I think, free through Visual Studio Express Edition, which is a free download. And then finally, the Debugging Tools for Windows package is a free download from Microsoft. And the tool that I'm going to use from that is the main tool in that package, WinDebug, or WinBag, it's called by developers. That's an application and kernel debugger. And I'm going to be using that to look at crash dumps. So let's get started with the outline, starting with a real case of sluggish performance. And this one was sent in to me from somebody that had seen the case of video, read some of my blog posts, and run into this shortly after, where he installed Half-Life on his gaming system, launched it, and Half-Life stuttered so badly, the responsiveness, it was so poor that he couldn't even get past the menu to actually play the game. And a web search he performed showed that other people were experiencing the same kind of problem with half-life, but nobody had come up with a solution. So he had to look for clues to figure out what was wrong with his system that was causing this behavior that most people didn't see. And for that, he turned to Process Monitor. And so how many people have used Process Monitor? Okay, I better ask the inverse question. How many people have not used Process Monitor? Okay, you're excused. So for those of you that haven't used Process Monitor, I know some of you didn't raise your hands that haven't used it, and that's okay. But Process Monitor is a replacement to FileMon and Regmon, the two of the original Sysinternals tools back from 1996. They're combined them together, add a whole bunch of filtering capabilities, add CPU tracking, add DLL load tracking, add thread activity, add scalability, massive scalability. I'm going to show you an example of just how scalable Process Monitor is compared to FileMon and Regmon. This tool will just show you underneath the hood of what applications in the system are doing with respect to the file system registry, threads, and DLLs. And kind of interesting, a performance problem like stuttering half-life, you wouldn't actually think, hey, let's run Process Monitor and see if we can troubleshoot that. But in fact, that's what this user did, was turn to Process Monitor. And David Solomon and I have come up with a kind of motto for Process Monitor, which is, when in doubt, run Process Monitor. No matter what the problem is, first thing, run Process Monitor. See if that has any clues. It often shows you the cause for error messages. You're going to see examples of that as we go along. And oftentimes, we'll show you the cause for sluggish performance. So let's take a look at what happened here. I'm going to switch over to the demo machine and show you the log file that he generated. So I'm going to fire up Process Monitor. And you can see we've got a filter here. I'm going to clear. And it's going to start generating real-time activity. So this is probably familiar output to any of you. The process name, the process ID, the operation, registry accesses, file system accesses, the path of the operation, the result code, and finally the detailed information for the particular operation. So this is a query basic information, so you can see that you see the actual information that was returned by that operation. And that's zoom it, by the way. And I bet you didn't know it could do that. So let's go ahead and load that log file. And I'm only showing you the tip of the iceberg of Process Monitor's features. You can add columns. There's a whole slew of columns you can add. You can dig in detailed process information. There's a whole bunch of ways to slice and dice the information that are built into automated data mining queries in the tools menu, like process activity summary, file summary, registry summary, and so on. But what I'm going to do is just show you kind of basic things here in the context of these examples. He ran Process Monitor. He set a filter just to look at half-life's activity before he launched it. And when he ran, he saw this. Now, this doesn't look good, does it? Because this registry value, the registry key path here that you see, has the name of a vendor, Zoo Brothers, that he didn't understand. He thought maybe this is the name of a new rock band or something that had put some software on his machine. He had no clue. And if you look at just how many registry operations happen in this trace, I'm going to go to the Tools menu and do a registry summary. You can see a total of 10,000 registry operations in this trace. And look, every single one of them is a reference to that Zoo Brothers registry key. So it looks like this guy is causing a problem. Now, who is Zoo Brothers? Well, for that, he did a web search. It turns out that this is the Zoo Brothers WISM IP and socket monitor, which is what he came up with, and found out by looking at his system that this was indeed installed. He had no idea how it got on his system. Uninstalling it made the problem go away. So Process Monitor led him right to the solution to that particular problem. Now, this next case I actually had sent in to me also by somebody that had seen the case of the Unexplained webcast. The scenario here is that in their enterprise, they've got a number of servers that they use to manage their server applications. And these servers are not supposed to be connected to the internet. They don't want people surfing the net off them. But what they found is that the applications on some of their servers, like the BizTalks MMC, Snap-in, SQL Management Studio, InfoPath, would start up very quickly, while other servers would take at least 15 seconds to show up after you launch them. And they were kind of perplexed about what was going on. So, of course, when in doubt, run process monitor. So they ran process monitor, and I'm going to switch to the demo machine. I don't have the log file to show you because he sent the log file in, but it's in an old format, process monitor's original format, so I can't load it into the new process monitor. I'm going to zoom in to show you what he looked for. He knew that he had a 15-second delay, and there was a ton of output in the log file, so what he did was look at the timestamps on the operations coming out of the snap-in for a gap of approximately 15 seconds. And you can see the highlighted line here is at 10:31:35, whoops, 10:31:35, and the next line is at 10:31:50, which is a gap of exactly, if my math is correct, 15 seconds. And so that led him to this part of the trace, and he looked around at what was going on before that gap, and he saw before it that there's a whole bunch of references to WinSock parameters and TCP/IP parameters, and immediately after the gap, there's a bunch of references to crypto functions. So he had a clue there. Something's going on with the network related to crypto. So the next thing he did was, what is going on? What's it trying to connect to for these crypto operations that are taking so long? And actually, I'm supposed to switch over to the presentation machine now. What he turned to was actually kind of interesting, because I don't know if in the same situation I would have used the same tool to pursue the investigation. So that just shows how you can take different techniques, different tools, and come up with a solution that might not be obvious to anybody else. It's a matter of looking for clues, however you think you want to do it. In this case, his instinct was to run Process Explorer and to look for some additional clues. Now, how many people have not used Process Explorer? And those people that have already raised their hands, they're already gone from the room, so on the process monitor one, so they're not going to raise their hands. So I think there's one person over there. Process Explorer is a task manager, super task manager essentially, and actually I use it to instead of Task Manager. How many people know that you could replace Task Manager with Process Explorer? So almost all of you, but a lot of you didn't. Let me show you how you can do that. So you can run Process Explorer, go to the Options menu, say Replace Task Manager, and what I've done with that menu option is made it so that any time the system or me wants to run Task Manager, no matter how I try to launch it, like here in the right-clicking on the taskbar, Process Explorer comes up instead. So let me hide that and show you again. Boom, there's Process Explorer instead. You could even do Start Run Task Manager. So why would you want to use Process Explorer and not Task Manager? There's a lot of information that Process Explorer shows you that Task Manager doesn't. Also, the way it shows you the information is a little bit different and sometimes gives you more insight into what's going on. If you look at this display, you can see that instead of a flat list of processes, you see a list of processes with some indentation. That reflects the process tree, and the process tree is essentially a parent-child relationship between processes. So this service host, you can see here, has 1, 2, 3, 4, 5 child processes that created from it. And so sometimes just knowing who created a process can give you a clue. I'm going to show you an example later where seeing where a process came from gave somebody a clue as to how to track down why that process was starting up using the process tree. You can see that you see a description of the image that's in that running that process. You can see the company name. That's taken from the image itself. There's no built-in database. And then you can see the CPU usage is more fine-grained than what Task Manager. Task Manager runs to the nearest percent. You can see sub-percents here for more accurate display. And then you can also see some color coding. The color coding is to help highlight different types of processes. So the pink, the beautiful pink, I think, is this processes hosting Windows services. Windows services are long-running processes that are independent of a user being logged onto the machine. And then you can come down here and see some nice blue coloration that highlights the processes that are running in the same user account as Process Explorer. So I ran Explorer when I logged in as my shell, and everything that Explorer created ran as me. So all of those processes are highlighted in blue because Process Explorer is also one of those processes. Anything that's white is a system process not hosting a Windows service or a process that's running in some other user's account. And so you can see things like WinInit and the Service Control Manager show up in white in that case. You can add a slew of columns to this display, showing you all sorts of extra information if you want it for easy access in the graphical view. This is just one of the panes of the multiple panes there you can see. There's process performance counters, process memory counters, so you can track for memory usage, handles, columns you can add to the other alternate views that I'll show you later. And then finally, you can double click on a process and get additional information about it. So let's double click on Explore, and you can see on an image tab information about it, including its command line, its parent process when it started. There's a performance tab with a whole bunch of performance information, CPU, I/O, memory. A performance graph that shows you the history of the CPU usage, the memory usage, and the I/O usage of that process. A threads tab that shows you the threads in that process. I'll talk about that later. Security tab, and this one is going to delay here for a second as it translates my security identifier into a displayable name. It's going to time out trying to talk to the Microsoft domain. And then you can see over on the right an environment tab that will show you the environment variables and a strings tab. Now, in this particular case, the user went to Process Explorer because another thing that it displays is the TCP/IP endpoints that a process has open. And that's one of the tabs I skipped right there. He went to the TCP/IP tab, and let's go back and I'll show you that before I show you what he saw. I'm going to click on a service host that hosts some services that are talking out on the network, like the Simple Service Discovery Protocol, which is universal plug and play. And you can see that Process Explorer will show you the UDP and IPv6 and UDP IPv4 endpoints and their states. And if you saw TCP endpoints, you would see the state of the TCP connection, and also if it's connected to a remote address, you would see that as well. So this user, when they went to Process Explorer and went to the TCP/IP tab of that MMC snap-in, saw that. They saw a TCP connection to crl.microsoft.com. Does anybody know what CRL stands for? And I'm sure there's Mark Manassi might know. Do you know, Mark?
Actually, there is a certificate revocation.
Oh, see if, darn, I should have blackened that out and then I would have got you.
Real certificate people pronounce it
Krill, okay. Thanks. Thanks, Mark. So what they concluded was that there were signature verifications of images being loaded in the MMC snap-in as the process started up. It was checking the Krill servers to see if any of the certificates had been revoked during the startup. Because those machines, remember, that had the delay didn't have proxy server configurations, they were timing out, trying to go out to that Krill server. So the solution here was for them, because they don't want these machines connected to the internet, that they went and turned off the proxy configuration on those machines that were. And what they did to address this problem was roll out a script on their machine where they push out the certificate revocation lists once a month to these machines and access them locally and point at them locally, so the machines don't have to go out to the internet. And that's something that they continue to do today. So here's another real-world example. This one occurred for me, and it was a machine in the kitchen that I don't use, but my wife uses to do her normal email and so on. And that machine was occasionally acting sluggishly, and my wife told me about it acting sluggishly. I just chalked it up to the fact that it was running Vista. But one day, she was like, I can't take this anymore. I just logged in the machine. It took me like 5 minutes to finally get to my desktop, and now I can't really do anything. So I went and took a look. I ran Process Explorer, which took a few minutes to start up. And when it had come up, I went and looked, and there were two processes consuming 100% of the CPU. Well, actually, this is a dual-core system, so each one had pegged one of the CPUs. They had perfectly sharing the total CPU usage at 50-50. One of those processes was IE, and the other one was DLL host. So interesting thing about these processes, because just knowing that those are the ones consuming CPU doesn't tell you a whole lot. It's unlikely that IE has a bug that's going to cause it to consume 100% of the CPU. And DLL host is another example of a process that hosts other extensions. It actually is just a container. It doesn't do anything. It hosts out-of-process COM servers. And there's a bunch of other examples of hosting processes in Windows, including Run DLL32, Service Host, and TaskEng. When you move the mouse over the process list in Process Explorer over one of these hosting processes, you're going to see the list of components that are hosted within it. So this particular service host has a whole bunch of services running inside of it. You can see through the tooltip here. There's TaskEng processes here. For TaskEng, Process Explorer will show you the tasks, the Windows tasks that are hosted inside of that TaskEng. And then for Run DLL 32, it will show you the target DLL that's being hosted in that Run DLL 32. In this case, it's some NVIDIA tray applet associated with my display drivers. For a DLL host in this situation, what I did was, well, first, one of the things that I did was suspend IE because I needed some CPU to actually do some troubleshooting. And with Process Explorer, you can actually suspend processes. So, for example, there's PowerPoint, and I'll suspend PowerPoint here by right-clicking and saying suspend. And that takes PowerPoint kind of out of the way, and I can't actually bring it to the foreground anymore. On XP, you would actually not even see it redrawing, because on XP, it has to respond to paint messages, but on Vista, the desktop window manager has cached the display of PowerPoint, so it doesn't need to respond to actually show the contents. So what I did was suspend Internet Explorer while I went and investigated the DLL host. I hovered the tooltip over the DLL host and saw that it was hosting that out-of-process COM server, the thumbnail cache class factory, which is a Windows component that's actually used to generate thumbnails. So this didn't tell me a whole lot either, because this isn't a third-party extension. Unlikely that this thing has a bug in it either. What I needed to do was dig deeper into what this thing was doing. I figured that something in that thumb cache DLL, something it was executing, probably a third-party component, was causing the problem. So to crack open a process and look inside it, you need to look at the threads. And before we talk about threads, let's talk about the difference between a process and a thread. We've been looking at, in the Process Explorer, at the list of processes on my machine. And processes are containers. They're reliability containers, and they also have a security identity. As far as reliability container, they host an executable image, multiple DLLs. They have an address space that they map those DLLs and the image into, as well as the data that they act on. They also, like I said, have a security profile that represents who is that process. That would be me and the groups that I'm associated with. And then they also have one or more threads that actually execute the code inside that process. So the thread is the execution unit on Windows. A thread is actually what hogs the CPU, not really the process, which is just this code and the data that the thread runs through. And all threads in a process share everything about that process, the identity, the resources that they have open, and so on. I want to mention here at the bottom that there's another hosting process that I didn't point out when I was showing you the other hosting processes, and that's the system process, which is a special process in Windows that hosts the threads, kernel mode threads that don't have associated user mode code. So these are system worker threads, these are memory manager threads, these are device driver threads. They live inside the system process. If you have an out-of-control system process, you can use some of these same techniques to troubleshoot it that I'm showing you here. So how do you view threads? Well, you can view them in Process Explorer. And what I'm going to do to demonstrate how we look at threads is first fire up a service that I wrote just for the purposes of demonstration that simply hogs the CPU. It's called service hog, and this thing is started up, and you can immediately see down in this, let me get rid of that fade, down here, that my CPU is basically on to about 50% utilization because of service hog. And if I go to Process Explorer and I scroll through, I can see here's the service host running at 50%. If I look at what's inside of it, there's service hog running inside of it. So this would be a case, if I encountered this in real life, that I'd have to go into that service host because I don't know what's hogging the CPU, in normal conditions, because normally you wouldn't write something like this. I would double-click, I would go to the Threads tab, and by default it sorts by CPU usage, and you can see that there's two threads that are hogging some CPU. Here's one of them, and this is what you get basically when a thread that starts within a service or within the component that's hosted in one of these hosting processes goes and hogs the CPU. You can see that its start address, which is there in service hogs DLL, You can see the start addresses of the other threads inside that service host. How does Process Explorer know the names of the functions? It's based on the fact that I've configured symbols for Process Explorer. So for the Microsoft components, it's going to know the start addresses here that you can see. And you can configure symbols over in the Configure Symbols menu entry. You're going to point it at the Debugging Tools for Windows package. There's a DLL in there. And then you're going to point it at a symbol server. Now, I've truncated the symbol server path here. What's missing here is HTTP. Actually, that's going to be too small. Let me do it here. Well, actually, let me just say that you can actually go and find the documentation for the symbol server path in the Debugging Tools for Help webpage, in the Debugging Tools for Help file, in my other webcasts. It's a very well-known string, http://msdl.microsoft.com download symbols. And that's what I would normally have there. The reason I don't have it there here is so that we don't have to wait for Process Explorer to go to try to find symbols for third-party components that aren't on the symbol server and cause us to slow down in the demos. So that's how it knows the start addresses. And I recommend that you go and configure Process Explorer to show you symbol information before you enter into deep troubleshooting. The issue here is that I've got two threads consuming CPU, and one of them tells me immediately what's going on, that one in the service hog thread. But the other one, if you noticed, was in a generic thread. It was the thread pool, TPP thread worker or something like that, which is a generic system thread that just does work on behalf of other threads that throw it work items. So and if I ran into that, I would know the cause of one of those threads hogging the CPU, the service hog service, and I could deal with that. But the other one would still be a mystery. And we needed to look even deeper to find out the cause of that one hogging the CPU. That's the scenario that I ran into on this machine, where a DLL host, inside of it, the thread that was hogging the CPU had a start address that points at quartz.dll. And quartz.dll is a built-in Windows DLL. It's part of the multimedia stack. So it's another case of a generic thread where I needed to dig deeper and see why was that thread consuming CPU. And the way that I could dig into why that thread was consuming CPU was to look at its stack. So what's a stack? So threads, when they execute functions inside of a program, one function calls another function, calls another function. How does the thread know how to get back to function 1 when it's in function 3? It stores that information in a per-thread region of memory called the stack. And so what it does is when function 1 calls function 2, it pushes onto the stack function 1's return address. When function 2 calls function 3, it pushes function 2's return address. Function 3 is where the thread's executing. When it finishes there, it will return to function 2 and then return to function 1. So looking at the stack of a thread that's busy consuming the CPU could give you a clue, because we're just looking at the thread start address in that threads tab. We don't know what that thread is doing right now. And the thread might have started its life in some generic system DLL, but it might have called into a third-party DLL, which is the one actually causing the problem. So let's go take a look at call stacks on this system where I've got this other service hog problem. So I've got this one, the TPP worker thread. Let's double-click and look at its stack. And what you're going to do when you look at one of these stacks is, again, look for the parts that aren't Windows parts. Because, again, if Windows has a bug, there's not much you can do about it, but it's unlikely that it's Windows' fault. It's most likely a third-party component's fault. And in this case, if we work our way up the stack, you'll notice that this is the address shown in the thread list as the start address of the process. This is the actual start address down here. The reason that I don't show that in the Threads tab is because all threads begin their life in a generic system function that is kind of the birth function for a thread. And that's not particularly useful. What's much more useful is seeing where the programmer said the thread should start its life, which is this one right here. In this case, this worker thread was being given work to do by service hog, and that's this right here. You can see that service hog is calling get tick count, and that's part of the loop where service hog's thread sits and figures out how much CPU to consume. So we've caught it in red-handed consuming CPU. Sometimes if you don't have a thread that's totally out of control pegging your CPU, it might be consuming some part of your CPU, you might have to do this, try to hit the stacks more than one time in hopes of trying to catch it actually inside of the guy that's causing the CPU-related problem. In this case, of course, we see that it's inside of service hog, and so we've solve the problem, identify the root cause of both of those threads consuming CPU and that service host. For the case that I had on my home system, what I found was this. The thread stack showed a third-party DLL. As I worked my way through that stack, which is pretty deep, I came across those frames there in a DLL sonic mp4 demux.ax. So the question was, what the heck is sonic mp4 demux.ax? Do I need it? Is there a new version? Should I uninstall it? Who made it? So I did a web search, and I found out that Sonic is actually part of Roxio. And what came on the system is a DVD authoring software. So I figured it was part of that. So I went to Roxio's website, saw that they had an update, downloaded the 200 megabyte update, waited 45 minutes as it installed, was all excited that my problem was going to be solved. I went and looked at the DLL. It was the same version. So they hadn't fixed the problem in the update. So it's kind of an hour of wasted time installing this update. But now I needed to figure out what to do about this. Why was that DLL getting loaded in the first place? For that, I turned to Process Monitor. But I needed to wait for a repro of the situation. So I terminated DLL host. I ran Process Monitor. And what I did is I configured it to log to a backing file. And let me show you how you do that. Because what I was going to do is actually, let me deal with this first. And the way that I'm going to deal with these guys is there's also suspend functionality on threads. So I'm going to suspend that, and then suspend that, and then you can see I've dealt with that problem. So what I did to capture this long-running event, I had no idea when the problem was going to reproduce. And by default, Process Monitor logs to virtual memory. And if you leave it running for a long time, there's lots of operations, and you might end up consuming all of virtual memory with the items in the list. So what you can do instead is actually point it at a backing file. So here you could say, ctemp foo.pml, and then Process Monitor will save the records to the file as it logs them into the display and not consume excessive amounts of virtual memory, which is what I did in this case. I pointed at a log file. Let's go open up that log file and see what I found. So the problem reproduced. I went to work, came home that night. The problem had reproduced. And so I searched the log file. Well, I looked through the log file for a reference to Sonic. And this will take a second because there's a lot of data here to get through. Page in. I figured if I found the reference to Sonic, that would tell me how that Sonic MP4 thing got loaded into memory. Give me some clue to work backward from there. And here's the hit. So the hit is actually on this. A registry query comes back with Sonic MP4 demultiplexer, which is exactly what I'm looking for. Now, what is the registry query that's returning that? If I look, it's DLL host doing a reg query value of this registry path. HKey class is root, class ID, and then you can see that there's a COM GUID here, global unique identifier. Then you can see that there's an instance component followed by another COM GUID right here, and then a friendly name. So what I'm seeing is that the Sonic MP4 demux thing is the friendly name for this very unfriendly name, which is the COM GUID. But the question is, what is that doing? How is that getting loaded there? So I did a little research on the web by searching for this GUID right here and found out that this is the GUID for the Direct Show multimedia extensions. And so whenever Direct Show kicks in, it's actually going to go enumerate the children of that registry key and load those COM objects into the whoever's doing Direct Show operations, in this case the thumbnail cache. So that's where the Sonic MP4 thing was getting registered. My fix there was to jump into the registry, because there's no way to go manage those things through any Windows tools. And the way that I jumped into the registry, I'm not going to jump in on that location because it doesn't exist on this laptop, but I'm going to show you that I right-clicked and I said jump to. Let me actually pick a little something more interesting. That's probably not there. I'll just jump to that path right there, and you can see it opens up regedit, takes you right to that key that was referenced, which is what I did there. And I deleted, actually I didn't delete, I renamed that instance GUID that pointed at the Sonic MP4 thing, just in case my system broke and I needed it back. So better to rename so you've got a fallback instead of just blindly delete. Well, I'm glad to say that I renamed it and the problem went away. And that solved that problem. Now I turned my attention back to IE, resumed IE, and looked at it in the same way. I went to the Threads tab, and in this case I didn't even need to go to the stack because it was a flash.ocx thread that was consuming 100% of the CPU. So I went to Adobe's site, saw there was an update for Flash, downloaded it, and I can say that that system has been free of both of those problems since I solved that. So my wife's a lot happier now, and I can sit in my office and not have to worry about managing her machine. So let me talk about the next scenario, which is skipped right over that, application hangs. Now this is an interesting kind of application hang. This one actually happened to Dave. Whenever he'd log off his machine or try to shut it down, he would run into this dialog box right here, the hung app window. How many of you seen the hung app window? All right, everybody, I just wanted to do some exercise, get moving here. You can actually generate this one really easily. If you just go into Notepad, type some text, run Task Manager, go to the Task tab and say end task. And what that does is Task Manager sends a message to Notepad saying, hey, time to go. Notepad says to you, hey, do you want me to save this? Task Manager sits there and waits for a while. It's actually not Task Manager, it's CSRSS, the client-server runtime system. Waits for Task Manager to respond to that message. Task Manager doesn't because it's waiting for you, and then you get that message box that says, hey, Task Manager's not listening to me. Do you want to kill it? Which looks like that. In most cases, when you get one of those dialog boxes, you can look and see what the program is that's not responding. But in this case, Dave, when he looked at the title bar, saw that the program was sample. So he didn't know what program named sample he had installed on his machine. No software called sample. No visible program called sample running. So now, how does he figure out who's responsible for that sample window? Because that's the title of the window that it shows there. So for that, he turned to Process Explorer. Because Process Explorer has a way that you can associate windows with processes. Task Manager does too. You might have seen that if you go into the task pane of Task Manager, you can say right-click and say take me to process, and it will take you to the process list to the process that owns that window. Process Explorer has a similar capability, and I can show you that here. For example, you just take this bullseye, you drag it over somebody, like I'm going to drag it over IE behind here, and it takes you to the process that owns that window. So he did that in that case, but like I said, it's not the process itself that shows you that's responsible for that window, that terminate process window. It's actually CSRSS. So in that case, it wasn't very helpful. Client-server runtime system. So his next step was to dig in and figure out which process owns a window called sample, that has sample in its name. And the tool he used was SPY++. Let's go take a look at SPY++. SPY++, you simply run it. It shows you a list of all the windows on the current desktop, both visible and invisible. The ones that have faded icons are the ones that are hidden windows. You can see there's a lot of hidden windows. Applications generally create a lot of them. And they use these for transmitting messages and for quick coming to the foreground. If you maximize it or show the window, it doesn't have to rebuild the window. It can just show it. And with SPY++, you can identify what process owns any individual window. The way you do that, and let's just go pick one of these random things that we'd have no idea who belongs to it. One of these generic tooltips, class 32, is you click on the properties, you go to the process tab, it shows you the process ID, which isn't too helpful, but if you click on that, it tells you which process owns that. And in this case, it's Explorer that owns that. So Dave did that, and you can see, following those steps, he did a search in SPY. You can also do a search instead of having to scan the list manually looking for window titles. So he did a search for sample, found that entry there on the left, right-clicked, went to the process properties, went to the PID mapping, and saw that it was ZCFG-SVC, which kind of looks like a developer that just took his knuckle and ran it over the keyboard when he came up with the name of that image. So ZCFG-SVC, what the heck is that? Some of you might know. Does anybody know offhand? Zero configuration service? You know, what is it for and who makes it? Wireless, right. And Microsoft doesn't make it, actually. If you look, that's who makes it right there. zcfgservice.exe. So he ran Process Explorer to see where that process was. Like, maybe he can figure out how it got started from Process Explorer. So he runs Process Explorer. He sees it there as a child of WinLogon. And you can see that its description is really helpful. 0CFG SVC MFC application, because developers are really proud that they can program MFC applications. And I'm always really excited when I see an MFC application on my system, because I know that really means high quality. And it's from Intel Corporation. So how did this get started? It's a child of WinLogon. WinLogon is the process that manages your interactive logon screen and taking your credentials as you log onto the system. So the next thing was to run a tool that would tell them how auto starts are configured. And let me ask, how many people use msconfig when you're looking to see how things get auto started in your machine? So, you know, msconfig, running that to look for auto starts is kind of like walking into a room with both hands over your eyes and looking around. And the reason I say that is because it shows you almost no information about what auto starts are there. First of all, it shows you a very tiny subset of the actual auto start locations. Second, for those that it shows you, it doesn't give you a whole lot of information. It doesn't tell you necessarily how it's registered to start or even necessarily who made it. So the tool to use, actually, you should all switch to Autoruns. Autoruns is a Sysinternals tool. I'm going to run it here on the system. And the number of items that you see here in this Everything tab, which shows you the aggregate of all the different categories of auto starts on this system, should give you an idea of just how much more information it displays than msconfig. From everything to basically the logon tab is the equivalent of what msconfig shows you. You can see Explorer, shell extensions. You can see IE browser helper objects, scheduled tasks, services, drivers, boot execute, sidebar gadgets, and the list goes on and on. Everything is in the Everything tab, of course. This list is pretty overwhelming when you run Autoruns. If you're looking for something, or if you're just looking for, hey, what kind of junk is loaded on my machine that didn't come with the OS? So a tip on zooming in just on the stuff that you're interested in that's most likely to be causing you problems is to go to the Options menu, say Verified Code Signatures, then click Hide Signed Microsoft Entries, and then what you can do is do a refresh. And then you can see that that list gets a lot narrower. And you can see down here, this is how Zoo Brothers, by the way, registers itself. Let me stop here and show you. Zoo Brothers registers itself as a WinSock layered service provider so that it can see all traffic. And I installed it on this machine just so I could see exactly how Zoo Brothers operated that thing. Now I'm going to install it afterwards, after I get done with this session, of course. So Dave ran Autoruns, and he saw this. Two components in the WinLogon notification DLL auto start points. IGFXCUI and CBring, both from Intel, have, again, very descriptive descriptions that tell you exactly what they're for. So he could tell immediately, right, which one was ZCFG Services parent. It's obvious, isn't it? Actually, it's less than obvious. He didn't know which one of these is the one that's causing the ZCFG to start up. So he needed to look inside those images to see if there was a clue there about which one's responsible for launching ZCFG service. Anybody guess what tool he used to look inside the image? Strings, right. He used strings. So strings is another Sysinternals tool. It's like this Unix strings utility. It will just jump the printable characters inside of any file you point at it. Well, I'm going to show you strings over here on my system, because there's a DLL here sitting in my system32 directory. inetwh16.dll that has no version information. No publisher, description, product, version, file version. And it's not digitally signed, of course. So the question is, what is this DLL? And I'm going to use strings to look inside of it and see if we see any clues. hit W, and pipe that through more. And immediately, what comes out is that this is the Internet Wizard, version 1. It's a little old. And it's from Blue Sky Software. So Blue Sky Software is actually a company that went out of business in 2001. I don't know how this got on my machine. I don't know what it's for. But now, instead of just wondering what INET-W whatever is, I have some idea of what it's associated with, just in case I want to run, I guess, some 16-bit apps on my system, which I typically don't do anymore. When Dave ran strings on those DLLs, he ran across this one on lgnotify.dll. zcfgservice.exe reference right there in the strings output. So he did a find stir to just grep for basically hits on that string. So that told him right away which one it was. So the case was solved. He knew that CCFG was responsible for that dialog during his logoff. He knew that it was part of Intel's wireless configuration. He knew that it was registered as a WinLog notification DLL. And he knew which, or it was launched by WinLog notification DLL, knew which one launched it, LG Notify, and at that point was safe in being able to uninstall the Intel wireless package because the built-in Windows wireless capabilities was, he actually didn't need the value add that the Intel thing was providing him. So let's take a look at error messages now. This case is one I ran into myself on my own system a few months ago. I was right-clicked on a folder, and I said send on the bunch of files in a folder, and I said send to compressed file in the Explorer menu. When I did that, I got this error message right here: file not found or no read permission. I retried it a few times. I got the same error, and then after another couple times, I managed to successfully compress the file. Question was what was going on. So the thing was so easy to reproduce that I fired up, of course, Process Monitor to look at what was going on. And this is what I saw when I ran Process Monitor. Oh, by the way, I forgot to point out, I was going to tell you about the scalability of Process Monitor. These are the number of events that were logged in that one-day period before I got the repro on that DLL host problem. Now, that's way, FileMon and Regmon would fall apart at about 100,000 events. So this is a pretty dramatic increase in scalability. Oh, that's what I wanted. So let me go open that, compress. So the thing that I was challenged with here was figuring out what was interesting in this trace. You can see there's a whole bunch of error codes in that result pane. And it's paging and stuff in, so there's going to be a short pause here. And so one of the techniques of being able to troubleshoot effectively is knowing when a result code that's not success is interesting and knowing when it might not be interesting. And some of that is just kind of art and just getting used to the way the system normally behaves. Just to give you an idea, actually, let me show you. On a system that's running normally, healthily, let me just go and do a few operations. Go back to the Tools menu and say Count Occurrences. So I'm going to show you the number of unique results codes that we see in this output. And here it is. So these are all technically errors, although these are errors that are expected errors. So the question is, which one, when you're looking at for a problem, is which errors are the ones that are real errors causing the application to misbehave? What I did was scroll down to find out the references to the file that was being compressed. Oh, I need to load the log file. That would help. And I ran into this. Well, to Explorer. I was looking for where Explorer ran into problems. So here's Explorer opening the target zip file about.zip and getting a sharing violation. So why was it getting a sharing violation? A sharing violation means that some other process has that file open, and it has it open in a way that's incompatible with the way this one wants to open it. There shouldn't be any other process having this file open, but if I look at the line immediately before it, there's Inoculan opening that file right before it. And if you look at the sharing modes, it says that it wants to share with, for anybody that wants to read or write this file, that's cool with that. But if you look at the way that Explorer wants to open that file, it's saying, hey, I don't want to share it with anybody. And so those sharing modes collide, and thus the sharing violation. Explorer at this point gives up. You can see Inoculand go on happily scanning the file here. It's highlighted, demonstrates how you can use highlighting in Process Monitor. And then I ended up with that dialog box. And actually, I can recreate that for you here. Let me just go into my demo folder. I'm going to select some files, send to, compressed file, and then you can see Transact Demo. And let's search for sharing violation. And that's not interesting. Here's one on Transact Demo, sharing violation. Why didn't I see the dialog though? You can see Explorer retries. There's another sharing violation. There's another sharing violation. Another one. Another one. Another one. Explorer is pretty persistent. This is an SP1 change. The problem that I ran into was RTM. So the behavior change in Explorer, it actually tolerates some amount of sharing violations where it would retry. And eventually, in this case, it succeeds because it happens to get into a window when Inoculand's not interfering with it. So what I did was, when I ran into this, I emailed the Computer Associates guys, and I told them about this problem. And you know what they wrote back? They connected me with their engineers that work on this, and they said, yeah, you should probably just turn off scanning of zip files. It's not really a security feature anyway. So my workaround actually was to go a little bit further. I just set a filter for C:/ in Inoculand so it wouldn't scan anything on my system. And dealt with that problem. This one was sent in to me by somebody just a few weeks ago. They had moved their user profile from D:/MyData to another location. So they're one of the people, I don't run into many people that have their profile in some non-standard location, but they did. They deleted their old profile directory after they made the move. But they noticed that the directory kept on reappearing, and they were wondering, how the heck is this going on? So, of course, they ran Process Monitor, and let me show you what they saw when they ran Process Monitor. They noticed a coincidence between running IE and that directory appearing. And you can see they set a filter just for their old profile directory, and this is what popped out of the filter. You can see Internet Explorer looking for that path that was configured, my docs, my pictures, and here you can see it actually creating the subdirectories. Here it looks for my docs, gets a name not found, so then it creates it. And then a little bit further, it gets a not found on my pictures, so it creates it. Question was, this is coming out of Internet Explorer. We know that Internet Explorer hosts things. What inside of Internet Explorer was causing it to do this? And some of you might not know about the ability for Process Monitor to show you the stack of an operation. In other words, the thread's function call history down into the operation that Process Monitor sees in the kernel, showing you potentially the root cause up the stack of who was responsible for this operation. So what they did was right-click and said stack. Now you interpret this the same way I've been talking about the other stacks. So here the thread began its life in the generic function, and then it went into IE frame, the generic IE thing, then it went into win32k.sys. Oh, but look at this. This is not a Windows DLL. It's basemod.dll, and if you look at the path, this component of the path gives it away. IE Pro. How many people run IE7 Pro? So those of you that have not heard of it, I recommend it. It's actually a pretty cool extension to IE. It gives you some nice features like a better way to search for text on a page and some other things. And so what he did was go back to IE7 Pro and wondered, hey, why is this thing creating that directory? So we went to IE7 Pro settings, and you can see there in the base settings down at the bottom is a directory that you configure when you want to do a quick picture save. It will save it to that target directory. And it looks like what happened is that IE7 Pro, the first time he ran it, looked for where his profile was and cached that information. And so even after he moved his profile, it was still pointing back at that location. So his fix was to change that. What I did actually before, as I was preparing for this session, was to reproduce that case. And I can show you that IE7 Pro, I don't want to pick on it, but if I go here, let me turn on Process Monitor logging, and if I go to its base settings, and I change this directory to someplace, like C demo pictures, it looks like that change took, but if I go back and look, it really didn't. Now, what happened under the hood? Well, there's a bug in IE7 Pro. Actually, let's just look for C demo pictures. And I can see here an access denied by IE7 trying to create that directory. Why did it get an access denied? It has to do with protected mode Internet Explorer. It's an ability to create things outside of the sandbox that it's in. And it looks like the developer for IE7 Pro hasn't made the tool, the extension, fully compatible with Vista. Okay, next topic is application crashes. So let me set the kind of framework here. I've almost never, actually up to now, I've never talked about application crashes because most application crashes, there's not a lot you can do with them. If notepad.exe crashed, if food.exe crashed, some piece of software you bought, it's likely a bug in that software. And the most you can hope for is that Process Monitor will show you some external condition that might have triggered that bug. But if it doesn't, and it's just some fundamental programming error in that software, you're out of luck. The most you can do in that case is either not use it, contact the vendor, and hope for a fix. But analyzing the dump is really what the developer needs to do to figure out where they made the mistake and how they can fix it. But a crash could be caused, like I said, from a misconfiguration. So first steps are to use Process Monitor to see if you can identify anything. Second step is to look for extensions that might have caused the crash in the crash dump. So the first thing is where's the crash dump? On pre-Vista systems, finding the crash dump is pretty easy because you get that we're sorry dialog, which that's kind of a, hey, you're really sorry for this. You click on the technical information that really doesn't mean anything button. You get that middle dialog, and you click on the really technical information that nobody cares about at all button, which points you at the dump file there. So that's the location for the dump file you want to go after. On Vista, it's a little bit harder because Vista by default doesn't save dump files. Only does so if when it contacts the Watson server, when you say, yeah, talk to Microsoft about this, the Watson server says, hey, we've seen a bunch of crashes like that. Yeah, we want to get a dump of this particular case to be able to analyze. And in that case, it'll save one. But most of the cases, it won't. So what you need to do is actually attach to the dying process. Because what happens is while that dialog is being shown, the process is in kind of a coma, suspended animation. And I'm going to demonstrate that for you by running a program, the only Windows program actually that Dave Solomon's ever written. It's called Acvio, and that's what it does. Now, Dave claims that he wrote this program specifically to do this. I think he actually was writing a real program and just eventually gave up. So what you do is run WinDebug, WinBag. Let me move this out of the way. You go to the F6, brings up the list of processes. You scroll down and find the one you're after, and then you say OK, and that attaches to the dead patient. And now you can perform the autopsy on it while it's kind of in this half-dead state. And performing the autopsy means looking for clues about what's caused the crash. And one little tip here before we move on to a real example of this is you can enable Vista to always save a crash dump. And this is what I recommend you do so that you can go look at your crashes yourself and troubleshoot them without having to worry about attaching to them dynamically like that. If you create that registry key there, local dumps, then it will always save a dump file by default to local app data crash dumps. And you can override the number of that folder as well as configure the number of dumps it will actually save with some additional registry values. Analyzing a dump is actually pretty straightforward and just requires WinDebug, configuring the symbols. You configure the symbols in the same way that I showed you for Process Explorer and Process Monitor. Once the dump is loaded, execute a bang analyze-v command. That causes heuristics to kick in that actually will look for a potential cause of the crash. Now, what you want to do is the exact same kind of troubleshooting we did for cases like when we were dealing with those hosting processes, is look at the threads, look at the stacks, look for third-party DLLs. Specifically, you want to look for threads that have had look like they caused a problem. And the way that you identify that is by looking for threads that have fault, functions with the name fault or exception or failure in their names. Once you identify a potential extension that's causing a problem, disable the obviously check for a new version of that extension software. If you can't find it, try disabling the extension, see if the crashes go away, or uninstall it. In this case, this is from my home gaming system. I encountered this a few months ago, where normally I don't do a lot of Windows Media Player work, and I started to go view some content one day that was delivered through Windows Media Player. And so I'd launch Windows Media Player. You can see that I'm doing a lot of real good work there. It's work-related. The name of that video is Monkey. It's actually a really funny video. Search for YouTube for Monkey. Actually, there's lots of funny videos with monkeys on YouTube, I think. And Windows Media Player crashed, and I get this, standard crash dialog. Of course, because a crash wasn't saved, I have to connect to it with WinDbg. So I connect to it with WinDbg. Let's go back and take a look at that crash dump. So I type Control-D, which opens up the Open Crash Dump dialog. You can also get that through the File menu. And here's the dump. Now, what I do when I get a dump like this that I need to analyze is I open these two windows, the Calls window and the Process and Threads window. And you can get those through the View menu. There's Call Stack and there's Processes and Threads. I open those windows and then I put them side by side. What I'm after is quickly going through the threads looking for ones that have fault or error in them. And the way that I do that is I first select the first thread here. You can see the call stack for that thread at the time of the crash there on the left. Then I do, if I don't see fault or error or exception in it, I say down arrow, enter. Down arrow, enter. Down arrow, enter, looking for a thread. And I'm going to just do that really quickly, looking for the one that I discovered. I might have skipped it in my rush here. Yeah, I did. I think it's this one. Yeah. And there. I looked at this thread, and I saw lots of exceptions and failures. And then I look up the stack, and I find a third-party component, NV App Filter. So what is this component? I do a little research on the web, and NV App Filter turns out to be part of the NVIDIA Enforce. I think it's really unclear, because some people think it's part of the NVIDIA Enforce Game Priority Network filter. Some people think it's part of the firewall functionality that comes with the Enforce software. I can't figure out which one, but I go check for a new version of the Enforce software. There's no new version available. So now my task is to figure out how to disable this thing, which is causing Windows Media Player, and also probably causing other crashes on my system. So I use Autoruns to find the problem. And in this case, Autoruns takes me right to, if I do load, I can load the scan from that system. And if I search for NV App Filter, I found it right here, NV App Filter, a bunch of references, and look at the path. It's the same one as the Zoo Brothers used, a WinSock 2 layered service provider here extension. So what I did in that case was just disable, and I can't disable on a saved scan, but what you would do is just click on those buttons to disable it. I have a 64-bit system here, so there's another set of the 64-bit versions of that in the 64-bit layered service providers section. I disabled those as well, and the problem was completely gone. Never ran into it again. Finally, blue screens and system hangs. So crashes in the kernel mode occur when device drivers perform illegal operations, and the system wants to protect your data because they're privileged parts of the system. We don't want them screwing with your data. We need to stop the machine right away to prevent any corruption. When you reboot after a crash, you know that you get that, hey, send this into Microsoft dialog. And a lot of times, it will tell you what caused the crash. It'll say, hey, there's a new update to that driver here. Go download it. Or here's a Windows Update. We'll go and have a fix for you. But there's sometimes when it will just say, hey, a device driver caused the problem. What's going on behind the scenes, though, is that the crash is uploaded to Microsoft. It's being analyzed in an automated way using Bang Analyze-V. That oftentimes points at somebody that's probably the cause of the crash. And so the server's going, oh, I know who did it. I know who did it. It's this guy right here. It's this video driver guy. But it can't tell you that. Even if it's 90% certain, if it said, hey, you know what, we're 90% certain this video driver that you got from video driver company X caused your problem. there's a 90+% certainty that Video Driver X's lawyers are going to be calling certain lawyers at another company and saying, hey, we don't like you smearing our good name in public like that. So we say, yeah, we know, sorry, driver caused a problem. And it's up to you to actually go figure out what caused it. So to do this, you just need to be able to find the crash dump to analyze. And you can see the locations of crash dumps, depending on whether you're in Vista or down level client or server. Always just a rule, if you don't have to not memorize that, just look for the crash in Windows memory.dump. And if that's not there, then go into the mini dump directory. So this one I had sent in to me by somebody that had watched the case of class, saw how easy it was to do crash dumps. In this case, the Bang Analyze didn't tell him exactly what the problem was, but gave him enough clues to be able to find out what it was. So this crash dump looks like this. And he did a Bang Analyze-V. This is going to take a second. And it tells him session has valid pool on exit, AB. So he does a web search on Citrix stop AB, and he eventually gets led to this right here. Stop error message on a terminal server that is running Windows Server 2003 SP1 or Server 2003 SP2. Stop AB, session has valid pool and exit. Hotfix download available. So this, they downloaded the hotfixes to their Citrix servers that were experiencing the sporadic crashes, and the problem went away. Now, another case of a system failure doesn't exactly result in a crash. It's just the system locks up. We talked about hard hangs before. Troubleshooting those takes a step beforehand to be able to get ready. And either requires you to connect with a kernel debugger to the hung machine. In most cases, though, you can configure the machine so that it will crash on demand with the special keystroke sequence. And that way you can configure that is in that registry value right there, crash on control scroll. And then you can type a special keystroke sequence, right control, scroll lock, and manually crash the machine. Let me demonstrate that for you. So I've got a Windows XP VM here that I've configured that way. And I'm going to type right control, scroll lock. Boom. And if you haven't tried that, there's really something quite gratifying about it. If you just like the blue screen, though, you can just get the blue screen to death screensaver. You don't have to go to that trouble. So again, on one of my home systems, ran into a problem where this machine in the kitchen kept locking up, and it became escalated to a critical support call for me. So I go and configure the crash on control scroll lock, and I load that into the debugger. And when you're looking at a hung system, one of the things you want to do is look at the thread of each CPU, executing on each CPU at the time that you crash the machine. And you do that with the KB command. And I looked at that, and again, you follow the same techniques. Is there any third-party stuff? Actually, I just wanted to point out the way that the Bang Analyze actually works under the hood. It does a little bit of racial profiling, because the Bang Analyze goes, that's our stuff. That's probably cool. That's our stuff. That's our stuff. That's not our stuff. That's somebody, that's a third party. It's probably that guy. And it will tell you. Well, in most cases, it's correct. In this case, when I looked at the stack, well, this guy looks pretty guilty of causing my hang. WPN 111. This is a multiprocessor machine. You can see here by the fact that there's a 0 here. I'm on CPU 0. I need to switch to CPU 1. So I do that with the tilde command, do a KB. And on this other processor, the same thing. This driver looks like it's deadlocked with itself. Now, what is this driver? Well, a little research told me, I'm not going to reveal the name of the vendor here because I don't like embarrassing vendors, but let's just say they make a lot of gear for networking. And this was a wireless USB adapter driver. And so I did an LMKV to look at the version number, LMKV M WPN 111, and saw the timestamp on this thing. And that was old even for that time. Went to the website, vendor's website, downloaded a new version, and the problem was fixed. So that brings me to the conclusion of the session. Again, there's not a recipe book here for just, hey, I'm going to solve anything now coming out of this. It's knowing some tools, knowing some techniques, knowing what's possible, and seeing how other people have done it that I hope really gives you skills and the confidence to go after these things yourself. And I want to say that you're not going to get good at this if you don't do it a lot. One of the things that I do is when I run into a problem, if I have time, I go spend the time to actually try to figure out what it is. And a lot of times I come away empty-handed. It would take way too much time to get down to the bottom of something. But a lot of cases, 50% of the case or more, just a process monitor trace, process explorer, thread stack, will lead me right to the cause of the problem. There's some other resources you can follow up with. My blog actually has a bunch of these case ofs. It's a theme that I started several years ago of documenting these things, and there's a couple of examples from today that are actually written up in blog posts. My webcasts link off of Sysinternals is where you'll find the other case of webcast. You'll also find other webcasts on using Process Monitor and Process Explorer. Windows Internals 4th edition, the internals book that I wrote with Dave. Highly recommend that book. Really well written. It actually comes in two covers, a black one and a blue one. I highly recommend you get both to get the two colors. And then finally, there's a Sysinternals video library that Dave and I produced, which is me and him blabbing this kind of stuff in depth on a few of the tools. We did it before I came to Microsoft. He's still selling it off his website. And in conclusion, I hope that you guys go back and solve some real-world problems. If you solve some problems, get screen snapshots, document the steps you follow, get the log files, send them in to me, and I'll send you back a copy of Windows Internals, and that way I can share it with other people. Now, how many people think you're going to go back this week and solve a real problem with this information? Or next week. Yeah, this week we're not doing anything anymore. Well, that's great to see. All right, thank you very much for coming. Please goodbye, fellas.